Like changes in demand, changes in supply influence the equilibrium price and quantity in important ways. Let's explore how that happens. Consider what happens when supply decreases, as represented by a leftward shift in the supply curve. We'll use the example of the ruptured gasoline pipeline in Phoenix, Arizona, first discussed in Chapter 5. As a result of this disaster, the quantity of gasoline available for sale in Phoenix decreased at every price. Now we can consider how this event affected the equilibrium price and quantity of gasoline in Phoenix. This figure provides hypothetical supply and demand curves for the gasoline market in Phoenix. In the month before the pipeline broke, the market for gasoline in Phoenix was in equilibrium, and that would be at point E1, right there, where the original supply curve, which is S1, right here, intersected the original demand curve, which is D1, right there. The equilibrium price was $2.50 per gallon, and the equilibrium quantity was 4 million gallons. But after the pipeline broke, firms were willing to supply less gasoline at each price. This shifted the supply curve for gasoline leftward to supply 2. At the original price of $2.50 per gallon, the quantity demanded would be right here, and the quantity supplied would be right here. And so there would be too much demand. Demand exceeded quantity supplied. So at the original price, because of this, the resulting excess demand pushed the price up to the level at which the new supply curve, S2, right here, crossed the original demand curve, D1, right here, at a new point, which we will label the new equilibrium point of E2. Now, at that particular price of E2, the price of gasoline rose to $3 a gallon, and the equilibrium quantity decreased to 3 million gallons. As you would expect, drivers in Phoenix were not very happy about the 50-cent price increase. Their wallets felt the effects of the gasoline pipeline rupture, and so they decreased their demand for gasoline. As a result of that, the quantity demanded decreased. A supply curve can also shift in a rightward direction, indicating an increase in supply. Consumers like this much better. This figure provides a simplified version of what happened in the Florida strawberry market between 2010 and 2011. In the spring of 2010, the market for Florida strawberries was in equilibrium, and that would be at point E1. That's where the original supply curve, right here, S1, intersected the original demand curve, which would be, I'm sorry, I pointed to the demand curve there, but the original supply curve would be right here. And that's where they intersected each other. Now, at this price, the equilibrium point would be E1, and therefore, the price of a pound of strawberries was $3.50, and the quantity sold was 205 million pounds. Equilibrium price and equilibrium quantity. In the spring of 2011, however, strawberry producers found that their fields were producing far more strawberries than in 2010 because of an unusual combination of sunshine and rain. An abundance of fruit made producers willing to supply more strawberries at each price. Supply increased, and the supply curve shifted rightward from supply 1 to supply 2. This shift caused an excess supply. Why? Because at that particular price, the supply would end up being right here, but the demand would end up being right here. So we end up with too much supply. And as a result, the price fell, and the market moved to a new equilibrium point as the price falls and it moves to E2. And that's the intersection of the new supply curve, S2, with the original demand curve, D1. Now, at this new equilibrium price, notice what happened. The price was now falling to $2.50 per pound, but the quantity demanded and supplied increased to 246 million pounds. Buyers were delighted with the lower price at the new equilibrium. They were left with more money in their wallets to buy additional goods, including more strawberries. Now, sometimes simultaneous changes in supply and demand cause both the supply curve and the demand curve to shift at the same time. For example, the supply curve for gasoline could shift because of a pipeline accident, and by coincidence, at the same time, the demand curve for gasoline could shift because of the introduction of a popular new electric car. In this example, both the supply curve and the demand curve would shift to the left. Notice that, okay? In other cases, the curves both shift to the right or they shift in opposite directions. In this section, we consider how shifts of both the demand curve and the supply curve affect the market. This first example shows the initial equilibrium point in the gasoline market at E1, at the intersection of the original demand curve, D1, and the original supply curve, S1. At E1, the price of gasoline is P1 per gallon, and the quantity of gasoline supplied and demanded is Q1. The pipeline accident causes the supply curve, however, to shift to the left. At the same time, the popular new electric car reduces the use of gasoline, so the demand curve also shifts to the left. The new equilibrium point is now at a point called E2. And that is where the new demand curve, D2, intersects the new supply curve, S2. The new equilibrium quantity is now Q2. This is clearly lower than the initial quantity of Q1. This makes sense because both the decrease in demand and the decrease in supply cause the equilibrium quantity to fall. So the combination of these two decreases will definitely lower the equilibrium quantity. But notice that the way the graph has been drawn, the equilibrium price remains at P1. This won't always be the case. When both curves shift to the left, the new equilibrium price could be lower than, higher than, or the same as the initial price. It depends on which curve shifts more. If the demand curve had shifted leftward by more than the supply curve, the price would have fallen. If the supply curve had shifted more, the price would have risen. These two possibilities are raised in the next couple of examples. Now, if you look at this figure closely and make sure you understand why the price in this example can stay the same, rise or fall, depending on the size of the supply shift relative to the demand shift. Now, this one shows that if supply decreases less than demand, price will decrease and quantity will decrease. Notice what happens there, because the shift of the demand curve is greater than, whoops, let me go back to the previous one. Notice here that the shift of the demand curve is greater than the shift of the supply curve. And so when that happens, not only does the quantity fall, but the price will fall. But what if we move those curves in the same direction, but in a different way? If supply decreases more than demand, price will increase and quantity will decrease. Notice here we're shifting both curves to the left, but notice the shift of the supply curve. Notice that the shift of the supply curve is less than the shift of, the shift of the supply curve is greater than the shift of the demand curve. And so even though they're still moving both in the same direction, because now supply decreases more than demand, price will increase in this case, and the quantity will decrease. So it matters, the magnitude of the shift of each curve as to whether or not the price will rise or fall. Now, let's look at this example here. This illustrates these particular changes. In this situation, the price will definitely fall because each of the shifts by itself contributes to a drop in price. So the two shifts combined are guaranteed to bring the price down. The way this graph has been drawn, the the equilibrium quantity remains at Q1, and the decrease in demand alone would cause the equilibrium quantity to fall, and the increase in supply alone would cause the equilibrium quantity to rise. So in this particular case, the two changes balanced each other out, resulting in no change in the equilibrium quantity. If the demand curve had shifted a bit more to the left, the equilibrium quantity would have fallen. If instead the supply curve had shifted a bit more to the right, the equilibrium quantity would have risen. Now, it's easy to get intimidated by these double shifts. Even when two curves shift at once, it's easy to track what happens to equilibrium, price, and quantity. The key is to focus on the new and old equilibrium. Don't worry about the mess of lines on the graph. Here are 4 steps that will help you. Okay. First, identify the initial equilibrium at the intersection of the initial supply and demand curves. Then label the corresponding price and quantity as P1 and Q1. Then identify the new equilibrium at the intersection of the new supply and the new demand curves. Then fourth, label the corresponding price and quantity as P2 and Q2. It will then be easy to compare the new and old price and the new and old quantity, despite a graph that resembles a plate of spaghetti. Now, this table here summarizes how various changes in supply and demand affect the equilibrium price and quantity of a good. For example, if supply decreases and demand is unchanged, then the equilibrium price must increase and the equilibrium quantity must decrease. Remember that for both supply and demand, a rightward shift represents an increase and a leftward shift represents a decrease.